So we are talking about Pascal's triangle. We are talking about binomial expansion. And so here we have Pascal's triangle. Now Pascal's triangle, as you can see, oh, wow, I'm really struggling. Okay, thank you. Complete the pattern below by writing the next row. So remember, you're adding 1 plus 4, and the answer to 1 plus 4 goes underneath in this box underneath it. 4 plus 6 you add, and the answer goes underneath. That's 10. So my next row always has a 1 at the edge on the left and on the right, but in between the 5 came from 4 plus 1. This 10 came from 6 plus 4. This 10 came from 4 plus 6. Okay. The next row is like the 5 plus 10 added up, 10 plus 10 added up. And here's the last row, but this is definitely not the last row of the triangle. This triangle can be written forever. In fact, when I was in high school, our teacher had us sit for like 15 minutes and just write down as much as we could of the triangle. It's an addition, it's adding the entire way down, but there's thousands and thousands and thousands and thousands of rows if you keep going, okay? So the binomial expressions are expanded. Is there any type of pattern developing that might help us understand more quickly? So we're gonna look at the patterns when you go to the second power, the third power, the fourth power, and here's what we've got. An exponent is like 2, so here's the 0 power. A plus b to the 0 power. Anything to the 0 power is 1. A plus b to the first. Well, that's really still nothing, it's just a plus b. A plus b to the second power. That's a perfect square trinomial. You square the first number, you add up the a times b, you double it, add them up together, and then the last is b squared. Yesterday I did sum of cubes. This is sum of cubes. This a third, 3a squared b, this is sum of cubes when you actually multiply everything out. Now something I want to point out. Let's focus on a plus b to the third power. Everybody look at this, a plus b to the third power. Starts out with the third power. A then becomes the second power. A then becomes the first power. And then there's no a. B is to the first power. B is to the second power. Okay. In front of this a to the third, can someone tell me what number is in front of a to the third?
1.
1. There's a 3, there's a 3. What number is in front of b to the third?
1.
1, which means I'm going to look at my third 1, 3, 3, 1, and that's the coefficients that will help us solve. The fourth row does the same thing. 1, 4, 6, 4, 1. A plus b to the fourth. 1, 4, 6, 4, 1. Right? Fifth row, and so on. So these numbers from Pascal's triangle are directly related to us trying to multiply a binomial. What is happening to the powers of a as you move to the right? So look at all my red underlines. What's happening to a's?
The power is decreasing?
The power is
Decreasing?
decreasing, exactly. 2, 1, and then a to the 0. 3, 2, 1, a to the 0. A fourth, a third, a cubed, a squared, a to the first, a to the nothing. Likewise, look at my blue underlinings. What is happening to the powers of b as I move to the right?
Going up by 1.
Going up. B to the nothing, b to the first, b squared, b third, b fourth. So my first number in parentheses decreases, the exponents decrease. The second number in my parentheses, the exponent is going to increase, go up. Okay, good, good, good. All right, so here's basically this again. This C we're going to talk a little bit about later, but not today. And I think we're actually good. We're going to stop with that. Okay, so now, done with this PowerPoint, I'm going to go back to my sphere. So you guys need out your notes that look like this. So I posted those on Google Classroom. Again, this is not something we're going to focus on. What you do need to remember is basically this. The powers of A go down one at a time. The powers of B go up one at a time. So that's the actual only thing you need to write on the front. I continued on with Pascal's Triangle a little more, but again, you have this on the paper that I also gave you. So what we're going to do together is we're going to practice this. And I'm going to show you how Pascal's Triangle can help you find, A plus 5 to the 7th power, something really large. Okay. I understand that the photocopy did not turn out so nice. So can you guys take a second and write down 1, 2, 3, and 4? Your homework is going to be 3 and 4, okay? You're doing numbers 3 and 4 for homework. You're not going to do 5. You're doing numbers 3 and 4 for homework. Okay. So let's begin. What I want to do is I want to be able to multiply A plus 3 to the 5th power. So I'm going to show you how I'm going to use Pascal's Triangle and I'm going to set it all up. Okay? All right, so I know that this is to the 5th power. So that's going to be my 5th row of Pascal's Triangle. 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. Okay. Was that too close? Sorry if it was all blurry. The 5th row says, let me actually just have you focus. 1, 5, 10, 10, 5, 1. Now let's talk about what my first number is in my parentheses. A is actually just A. My B is going to be 3. So what I'm doing is I'm making, it kind of looks like it's going to be a chart, but we're going to end up using that to multiply and get our polynomial. So Pascal's Triangle was used for this, 1, 5, 10, 10. I'm going to multiply 1 times whatever I write, 5 times whatever I write. Here's row A. Or I'm sorry, here's the A's and here's the B's. Remember how we said that the A decreases and the B increases, right? So that's important for you to know. In the PowerPoint, I told you that the power of A's decrease. Now, if I'm at the 5th power, I'm going to start at A to the 5th, and I'm going to decrease down. A to the 5th, A to the 4th goes there. A to the third goes here. A squared, A to the first, A to the 0. So these are all my A's. Okay, my B's. The B values increase, so the exponent increases from 0, from nothing, all the way up to, what are we trying to find? The 5th. B has a value of 3. 3 to the 0. 3 to the first, and I keep them all lined up in rows. 3 squared. 3 to the third. 3 to the fourth. 3 to the fifth. So now the Pascal's triangle gave me like part of the coefficient. The A's, whatever number's in the first position of the parentheses, have exponents starting at whatever I'm looking for, the 5th power, going down. 5, 4, 3, 2, 1, 0. My B value was a 3, and that increased 0, 1, 2, 3, 4, 5. Rena, question.
For the 5th row, how do you like get those numbers? 5, 10, 10, 5, 1.
Oh, here. Look at the 5th row. 1, 5, 10, 10, 5, 1. This exponent means that I use this row. If I were going to the 4th, I would use this row. 6th power, I would use the 6th row. Okay.
Well, the A equals A and B equals 3.
That came from the problem that I was given. The example 1 was A plus 3 to the 5th power. I don't want you guys to do this 5 times. So instead of you doing this 5 times, I am teaching you a method to solve and find the polynomial without multiplying 5 different parentheses. So now I need to actually multiply across. So I'm going to do, like, these are all multiplied straight across. 1 times A to the 5th times 3 to the 0 power. Basically, guys, 3 to the 0 power is 1. 1 times 1. So all I really have here is A to the 5th. This next one, you're going to multiply. And notice, it has to be like this. Before I start multiplying, my exponents need to add up to 5. 4 plus 1. 3 and 2 make 5. 2 and 3 make 5. 1 and 4 make 5. The exponents need to add up to the power that I want. I want to solve a problem to the 5th power. 3 to the first times 5. 15. 3 times 5. A to the 4th. Chisholm, yes.
Oh, I was gonna answer. It's
Oh, okay, that's okay. Does somebody have a question?
So for the A row and the B row, it started off with A 5th because there's the 5th exponent. And for B, it started with 0 because that's the starting point.
The reason that B starts at 0 is because the exponents increase, and so you start from nothing and you go upwards. Nothing is 0. B is always, this B row, this row here is always going to start with a 0 power, 1st power, 2nd power, 3rd power, etc. Okay, moving on. 10 times 3 squared, 10 times 9 times A to the 3rd. You multiply all 3 of these things together. 10 times A to the 3rd times 9. 90 a to the third. Ten times a squared times 3 to the third. 3 to the third is 27. 27 times 10. 270 a squared. Three to the fourth times 5 times a to the first. 3 to the fourth is 81. 81 times 5 is 405. A to the first, 405a. 1 times a to the nothing times 3 to the fifth. 3 to the fifth is 243. So now, all of these products that I got, those are my polynomials. Like that's the answer to my polynomial. I'm going to write it out. A to the fifth plus 15a to the fourth plus 90a to the third plus 270a squared plus 405a plus 243. And you're done. So this is a lot more efficient than me writing a plus 3, and then deciding, wait, did I miss one? Am I on track? Did I get any numbers wrong? So we use Pascal's triangle and this method, binomial expansion, it's called. All right, let's do example 2. That's the last one we're going to do together. Now, A is just A. B is 2b to the third. So make sure that you write down what the correct math problem is, because it's blurry on your paper, isn't it? I'm going to the fourth power, which means that I'm going to go 4, 3, 2, 1, 0, and then 0, 1, 2, 3, 4 for my rows, or they're my columns actually. Reminder that A decreases.
Mrs. Grant, I have a
B.
question.
Yeah, go ahead.
So when you're trying to find the row that you get the numbers from, do you just like take the exponent and then add 1?
No, this exponent is 4. I don't add a 1 to anything. It's to the fourth power.
Oh, I mean, like for the rows, like that power plus 1 equals the row you go to.
Talking about the triangle?
Yeah.
The best way to do this is to say, if I want, let me make sure that this isn't blurry. If I want something to the second power, I'm going to use 1, 2, 1. If I want something to the third power, I'm going to use the coefficients 1, 3, 3, 1. I realize that the first row in your brain looks like that, but this is really, I guess, where my pencil is, we're going to say is the first row, second row, third, fourth, fifth. The number that is here on the edge corresponds with what exponent you're trying to multiply. So maybe the word row is a bad idea because they don't line up.
Okay, thank you.
Okay, so I'm doing the fourth now. The 4 is 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. So that means fourth, I guess I won't write fourth row if you guys don't like that. 1, 4, 6, 4, 1. Right? Okay. my A and then my B. My A is actually just A. That's the exponent. My B is 2b to the third. I have to be careful with this 2b to the third one, like really careful. Okay, so I'm gonna write underneath, I'm gonna put a to the fourth, a to the third, a squared, a to the first, a to the 0. Under B, I'm gonna put what my B is. My B is 2b to the third. So I actually have to do 2b to the third to the 0. Because that's what my second number in the parentheses was. Yes, Hannah.
I was gonna answer, but okay.
Oh, okay. I'm going through just because every period I ran out of time. So I'm just gonna, I think, hustle through. Next, 0, first power, second power, right? 2b to the third power to the first. 2b cubed squared. 2b cubed to the third cubed. To b to the third to the fourth. Again, please remember 4 plus 0 make 4, 3 plus 1 make 4, 2 plus 2 makes 4, because we are trying to do an expansion to the fourth power. All right, now I multiply 1 times a to the fourth times 2b cubed to the 0. So you need to focus your math skills here, because 2b cubed to the 0, that's just a 1. So it's 1 times a to the fourth times 1. Anything to the 0 power is 1. A to the fourth. Sorry, hold on. Four times a cubed times 2b to the third. Okay. This is basically 4 times 2, 8. Then a cubed, b cubed. A cubed, b cubed. Okay, now it gets harder because I've got 2b cubed squared. Okay, do 2 squared 4 times 6. 2 to the second power, 2 squared 4 times 6. 24. So I got my coefficient of 24. Then it's a squared b to the 3 times 2, right? Power to a power, b to the 6th. Two to the third power is 8. 8 times 4. 2 to the third power is 8. 8 times 4 is 32. That's my coefficient. A to the first, always alphabetical order. B to the 3 times 3. B to the 9th. Lastly, 2 to the 4th, 16 times 1. My coefficient is 16. A to the nothing, don't worry about it. b to the 3 times 4, b to the 12th. And this is my polynomial. Let me write it out. A to the 4th plus 8 a to the 3rd, b to the 3rd, plus 24 a squared b to the 6th, plus 32 a b to the 9th, plus 16 b to the 12th. So let me recap what I did. I looked at the math problem that I was given. This had a 5th power. That means that I looked to the corresponding 5 in Pascal's triangle. 1, 5, 10, 10, 5, 1. Each of those is going to be a different term. 1, 5, 10, 10, 5, 1. Then I said, what's the first number in my parentheses? That's my A. And I listed all my A's in descending order, 5, 4, 3, 2, 1, 0. Then I looked at the second number in my parentheses. That was a 3. So I listed my 3 in ascending order, 0, 1, 2, 3, 4, 5. Then I multiplied my Pascal's triangle number times my new first term and my new second. When I say term, I mean like the A first number and then the B the second number. Ah. So your job is just 3 and 4. Please make sure that you wrote them down properly. Example 3, you're not going to have enough room. You're going to have to do this on a separate sheet of paper or maybe to the side because we're not doing 5 anymore. X minus 5, all to the 4th power. X minus 5, all to the 4th power. That's example 3. You're going to do that one for homework. You're also going to do example 4 for homework. Example 4 says 2x minus y squared, all raised to the 3rd power.
Example B, with the, for example 4, would B be like negative y squared?
Yes, A is 2x, B is negative y squared. For example 3, A is x, B is negative 5.